so combining functions. This is kind of an introduction to what we're going to do for a couple days. But you've already kind of dealt with some of this stuff. Let's say that I have a function like f of x, and I'll just call it x squared. And I also have the function g of x, and let's call it, I don't know, some simple 2x. Okay? We understand what those two functions look like, right? X squared looks like that. 2x maybe looks something like that, right? We understand what those two functions look like. What we're going to do next is say, okay, we're interested in maybe what f of x plus g of x looks like. Okay? Well, algebraically, it's x squared plus 2x. It's whatever f of x was plus whatever g of x was. Okay? So that's kind of easy, right? All right? And that's kind of maybe something that you've talked about in the past, because we've dealt with that x squared, we've dealt with 2x, but we've also dealt with something like this, right? Okay? So the development of these new functions is basically combining, adding, subtracting, multiplying, dividing other simpler functions together. Okay? But understanding how these functions look and understanding how they operate will tell us maybe something about these. Okay? Now think about what this means. Okay? This is the y value of these functions is equal to some x value squared. The y value of this function is equal to 2 times some x value. Okay? Well, the y value of this function, f of x plus g of x, okay, sometimes written this way, f plus g of x, you can write it both ways. So that y value is simply these respective y values added together. Does that kind of make sense? So if I look at, just do this on GeoGebra real quick, some just very simple functions. If I have x squared as g of x, or f of x, g of x is going to equal 2x. So I got those two functions. Okay? And I'm going to actually add together, get h of x. Now let's do it this way. Let's go f of x, I don't know what to call it, plus g of x. Actually add those together. Okay, so let's call it h. But what's happening here, I put my grid back in for us. Put a perpendicular line in here at 1 just real quick. And we'll go intersect that line there, and that line there. And now I'm going to get rid of that line, but keep the points. And hopefully when I move A, it moves those points. Okay. So now I'm going to ask to find or display, I guess, the ordered pairs for those points. Okay. So what's happening here, okay, remember the blue one was the sum, right? The blue one was those things added together. And you can see that over here, that the blue is x squared plus 2x, is these two things added together. So if I take what's happening to develop this blue curve is that we're taking the y values from the green curve and the y values from the red curve, and we're adding those together for that x value of 1, and that becomes the y value of my new curve, the blue curve, right? Kind of make sense? Okay. So everywhere I move A, it's gonna see that pattern that you take that y value plus that y value, and it should give you that y value. And these x values should be consistent throughout all 3 points. So we get 1 plus 2 is 3. Okay, maybe I have y value or an x value of 2. Okay, so here we've got this point overlaps, it's an intersection point, so 4, 4, add those together. On the blue curve it becomes 8, right? Okay. If I come over here at 3, I get 6 and 9, so I can add those together, and I should get a blue point of 15. Okay? And that's really how we're developing that blue curve. That one right there is taking those y values of the other functions that we understand real well and just summing them together. Does that kind of make sense to everybody? Okay? But now we can do other things with those functions. We can not only add them together, but we can subtract them. Okay, so if I go f of x minus g of x. Well, that's going to look like x squared minus 2x, right? Okay, x squared minus 2x. So if I do that, just change this to minus. Okay? Now you see that when I change this, let's go back, zoom in on this one, get that to 1. Now you can see that, and order matters. Okay? So I'm going green minus red. So green was located at 1, 1. So I'm taking this y value, okay, minus this red value. So 1 minus 2 gives me negative 1, right? So I plot that point, negative 1, I get the blue curve. Same thing over here, okay? Those two things, now the order doesn't matter because they're the same point, but 4 minus 4 gives me that y value of 0. Come over here, okay? Green first, so I'm going to go 9 minus the 6, and it gives me the green value of 3. Sorry, the blue value of 3. But that's how I'm getting that blue curve from the difference of those y values. Does that make sense? Now, hopefully we understand, is subtraction commutative? No. So 2x minus x squared, so let's say, write this as g of x minus f of x. So I flip things around. You see that you get a different curve, right? But you get that different curve because if I'm back here, now it's the order of subtraction. So now we're going red 1 minus the green 1. So red 1 is 2 minus the green 1 of 1, and it gives me this blue point of 1. But if I'm over here at like 3, okay, we're taking, again, the red one, not exactly on 3, the red one of 6, subtracting from it the green one of 9, and it gives me this blue one of negative 3. So we get that order pair. Okay? We can do, when we do subtraction, we can do two different results. Okay? F of x minus g of x, or g of x minus f of x. So that's 2x minus x squared. That's often a question they ask you is when you combine functions, does f of x minus g of x equal g of x minus f of x? Okay? They ask that. Is it commutative? And the answer is no. Okay? In general, they are not. Okay? The next thing we can do is we can multiply them together. We can get f times g of x. Okay? Or just kind of keep the same notation. F of x times g of x. And I'll show you here in a moment the additional ways you can write these things. You don't have to write x twice. If I multiply them together, okay, that's simply x squared times 2x, or 2x times x squared, or do the algebra there, gives me what, 2x cubed? Okay? So because I take a linear function and a quadratic function, and now I multiply them together, we get that cubic function, and that looks just like a cubic, right? Okay? But it's a combination of those two things that allow us to create that. Okay? So what's nice is have somewhat of an understanding of these two, and now we have an understanding of a new curve. Okay? Or at least a foundation for understanding a new curve. Okay? Now, is g of x times f of x going to be the same thing? Can I multiply in any order so we get the same result? Yep. Yeah, so multiplication is commutative, so we're okay there. The last one is division, and division is the one that people struggle with the most. We've got the idea that we take f of x divided by g of x. Okay? So in this case, we have f of x being x squared, and then g of x being 2x, right? I can do some simplification there. We can rewrite that as x over, 2? Okay. And if we graph that, so if I see I did f divided by g, okay, gives me that f that that's it didn't cancel things out, but that's just x over 2. Okay. Now, I don't know if this is going to, see if I can get a table. I don't know if this has a table tool on it or not. We'll talk about some issues that might occur here at 0, okay, because of that function there on the bottom. So we'll talk about that in the next couple of days. That's part of this course. But we get a line, okay? But now if I do it this way, G divided by F, now we get that thing, all right? And hopefully you recognize maybe there's a bigger issue at that one, because when I take and revert, basically let's find the reciprocal of this, so I write G of X divided by F of X. G was what, 2X divided by X squared. Now they cancel and we get 2 over X. Well, what can X not be in this case?
0.
Yeah, because of this division, we can't let X be 0, so that's why we have, if you remember from last year, we call that an asymptote there at the y-axis. But that's, understand, that's kind of introduction, understanding what other functions look like. When we start combining them and dealing with them, we can kind of have an idea of what this new result is. And it's simply, remember, f of x is referring to y values, right? G of x is talking about y values. So when we combine them this way, we're adding those respective y values together for the same x value, okay? So if x is 2 here, we got to use the same x being 2 here. Does that make sense? And then add those outputs together, those y values together. Here it's the difference in them. The order of the difference matters, okay? Here you're taking those y values and you're multiplying them. Here you're taking those y values and dividing them. And again, the order of division matters, okay? So if we can do that with maybe those simple functions, maybe we can do it with functions that are a little bit more difficult, okay? Here are some alternative ways of writing. I'm going to zoom in on this real quick for you. Some alternative ways of writing f of x plus g of x. You can see it written this way here, which is probably the most convenient way of writing it because it's writing of x one less time. But what's really nice there is that maybe writing it this way tells you that you're using the same x for f and g. But all those are similar notations. Okay. Now, you see over there on the right-hand side, we're talking about new types of functions, and just like always, new types of function, we like to talk about its domain, right? Okay. So if we look at these and talk about the domain of these functions, the domain, and we'll do a specific example here in a moment. The domain, though, is, what's that word right there mean, or that symbol? Intersection, okay? So we're looking at where they do what graphically? Where they overlap, right? Okay, it's where the x values overlap, okay? Where they are shared. And here's the idea, and why we've got to pay attention to this. If we think about what we're trying to do, we're trying to add y values, right? Well, I can only add 2 y values if I know what both of them are, correct? Okay. So let's say I start you off with f of x being x squared. Okay. What's the domain for x squared? All real numbers. Okay. So negative infinity to positive infinity. Okay. And let's say that g of x, let's just say it's, let's do an easy one first. Let's go square root of x. Okay, what kind of numbers am I allowed to have underneath that radical? Say again? Non-negative numbers. That's a great way of putting it, okay? Because that means I can include 0, right? Okay, so that's my domain for that function, okay? Well, if I look at these two things together, okay, kind of going back to the way I set this up might be really useful for this idea. So f of x is x squared, but this is square root of x, okay? And now I want to talk about, let's just take f of x, let's do the easiest operation, plus g of x. I think adding is probably the easiest thing for us to do, okay? If I look at those two things right there, those are the two initial functions, right? And I look at, taking these points here, okay? Obviously you're seeing that point D being provided when I add, so D is the point that is on that new curve, right? Okay. So when I have an x value of 1, okay, I can take 1 plus 1 and get 2. When I have an x value of 1.5, I can take 1.22, 2.25, and get 3.47. When I have an x value of 2, I can take square root of 2, 1.41, 2 squared, which is 4. I should be able to add those together to get 5.41, right? Make sense, everybody? So, those points, because the domain exists for the blue, or sorry, the green curve and the red curve over here, I can add those y values together. But when I get over here, do we see a point D showing up here? Because I don't have anything to add together over here, right? Even though I've got y values for the green curve, I don't have y values for the red curve. Okay, so I don't have these points, these radical x points showing up. So I don't get a sum of things anymore. Does that make sense to everybody? So you don't have y values to add together over here. That's why in your final image, you don't have anything existing over here. You don't have any points over here. Does that kind of make sense to everybody? All right. So that's the logic. That's the graphical image and display of why, when we want to find the domain of f of x plus g of x, it is simply the intersection of the two separate domains. Okay? So if I want to find the domain of this, okay, without a graph, okay, we're going to think about this intersection. Well, if I think about this intersection, I like to think about it graphically first. I think, especially if you are a person that says, I've been bad at domains, I don't fully understand them maybe. The way you start understanding them a little bit better is to graph them real quick. Okay? If I've got negative infinity to infinity, okay, so this is f of x's domain, negative infinity to positive infinity. Okay, here's my number line, there's 0 right there. Okay? My domain for g of x goes from 0 to infinity. Okay? Intersect, okay, that symbol there means that we're looking for where they overlap, right? At what number do they start overlapping? At 0, right? And they continue overlapping towards the right. So continue overlap towards infinity. So that is my new domain for f plus g. Okay? And is that exactly the same thing that we found here? Okay? The new domain of f plus g is everything from 0 to the right, all the way up to infinity. Okay? Now, what's nice is that once we find the domain there for the sum, because they usually ask, like, in a homework assignment or a test, they'll ask you to do like 2 or 3 of these things. Okay? But once I find the domain of the sum, I now automatically know the domain, okay, of that thing. They're the same. Okay? So domain here, 0 to infinity. And it's all the same idea because now I should have 2 y values that I can subtract. Okay? So if I want to subtract these, and I'm getting that picture, okay, it's because we were able to subtract on the right hand side of 0, we're able to subtract the red and the green. Okay? But on the left hand side of 0, we don't have a red one to subtract from, right? Okay? So the domain of that new function is in fact still 0 to infinity. And when we find out that we can go g of x minus f of x, which is, think about it this way, just kind of write it this way. Is this still, if I subtract these in this order, most people are going to say, well, let's just write it as radical x minus x squared. Is that okay? Does that say the same thing? That's g of x minus f of x, right? Now these two things are different, but let's look at it this way. Could I just multiply this thing by a negative and got negative x squared plus radical x? Are those two things the same? Negative x squared plus radical x, same thing as radical x minus x squared. Those are the same. And this one was developed, so I can say that I can actually develop this thing here by simply multiplying this one by a negative, right? But when I multiply something by a negative, the whole thing by a negative, transformation-wise, what's that do? Reflected over the, what axis? X-axis. So I have g, if I go g minus f, visualize what this blue curve looks like right now, but when I change the order, It's just a reflection, isn't it? Okay. So that's something to maybe help us out and kind of visualize what's going on with some of these relationships. But that domain, look at that curve. Still start at 0, still goes to infinity, right? But the idea is to be able to find these domains maybe without the picture. Okay? But I want to combine the picture in this process of developing these functions so that you understand an idea of why these are what they are, why these domains are restricted. Okay? Now if we go, let's just do a division one here. If I go f of x divided by g of x. Okay? F of x is x squared divided by g of x is radical x. Okay? Now, what's my domain have to be? We still start with that. We still start with the intersection. Okay? But we should know because of division you can never divide by what? 0. So that's why here it says domain is an element of the intersection of A and B given that the bottom function does not equal 0. So the bottom function here cannot equal 0. So you guys say you can't be 0. So I kick 0 out, and that's how I change the domain. Okay? Well, tomorrow in class we'll start with a handful of those to kind of practice that domain and range concept.
Wait, when's the test?
Test will be next week sometime.
Oh yeah. Oh, my week has just gotten better.
Your week or your weekend?
My